Howdy everyone. Welcome to Netsync and Nokia's fixed wireless and private LTE session. We're excited to be here. We're excited to have you with us. My name is Dave Irek. I am the practice manager for the optical wide area networking and service provider business, which is including the fixed wireless and private LTE business. With me, I've got Joe Hayes.
Hi, I'm Joe Hayes. I am the solution architect leading the fixed wireless practice within Netsync, where we're looking at how we can help our K through 12 primary students now shift from being in the classroom to being at home, having to do their work from home now.
So Joe and I make up the fixed wireless business side and technical side. We've got a team of resources and engineers behind us to help support your initiatives. We're seeing a massive uptick in the demand and information gathering in terms of the fixed wireless private LTE and what that means not only for schools, for higher education, for the public sector. So the session we're going to do today is what is CBRS and private LTE. We know a lot of folks are trying to understand this and what the nuances and difference with that. So we've leveraged our great partnership with Nokia and brought in two experts to help us with that and understand the overall area of CBRS and PLTE. With that, I'd like to introduce Ray Sabourin. Ray, thanks.
Ray Sabourin. I'm part of Nokia's enterprise division. I focus on private wireless business development for enterprise.
And we also have Dharmesh. Tyagi.
Hey guys, my name is Dharmesh Tyagi. I lead the architect team in Nokia and the enterprise business as well.
Great guys, we really appreciate it. I know our audience is looking forward to understanding more about the CBRS and PLTE technology. So thanks very much for coming.
Sure.
Thank you.
So guys, when we talk about private LTE, what exactly the private LTE is actually? So private LTE in general, if you look at the data requirement we have today in the market, besides voice and other applications, private LTE is nothing but the same application that you receive from your service providers like AT&T, Verizon. Private adds a flavor of having your own network where you don't have to be dependent on the configuration, the capacity, the coverage from the service providers. Now, private LTE is having an evolution path. It's a very linear evolution towards 5G. So if somebody is deploying a private LTE today in the market, it's not really a 4G network actually, it's 4.9G network. So if you look at 4G network started in 2010, and at that time we were providing 100 megabits per second type of speeds. Today with the 4.9G, the speed limits are almost like a gigabits per second. Same thing with the latency. When you're talking about end-to-end latency, it takes almost like 50 milliseconds back in 2010, and it reduced to 10 milliseconds in today's date. With the 5G network, we are talking about 1 millisecond or less than 1 millisecond, whereas the throughput, we are talking about almost like 10 gigabits per second. Now, how do we take this private LTE network towards the 5G path? It's a very simple software upgrade type of network. So whatever the network you're deploying today in the 4G network, in private LTE environment, it automatically upgrades to 5G with the software click. So you download the software of 5G going forward, maybe next year or year after, depending on how the network lays out in your premises, you can have a complete 5G network. Now, what is CBRS actually? So when you look at the service providers, in order to transmit this wireless network, you have to have a spectrum. And generally, service providers, they spend millions and billions of dollars on this spectrum. CBRS is a way of providing from the government for everyone to utilize this spectrum as well. So they gave us 3.5 gigahertz in 3.5 gigahertz band, a 150 megahertz channel, which was used mostly by the navies and some incumbents. This spectrum has been freed for the public use. So there are 3 channels in the CBRS. One is called incumbent, where Navy radars or government officials, they can use this spectrum. There's another one which is called priority access license, PAL license, and there's a GAA, general available access. So in the general available, you have 80 and 70 megahertz between PAL and GAA. These spectrums are available for public to deploy the private LTE network. So the way they control this network is through a SAS network. Anybody using a certain channel from the private LTE network, they have been controlled by the SAS. It's a spectrum access, authority basically monitoring who is using what spectrum, so they don't interfere with each other. So combination of CBRS and private LTE is like a new revolution towards deploying, for the industries, for school district, campuses, and all these kind of things.
Yeah, and that's been the catalyst actually when thinking about, LTE is not a new technology, but private LTE is somewhat fairly new, at least in the US, and the catalyst to that was the CBRS spectrum. Now, enterprise has, and public sector and K through 12 schools now have access to spectrum, so now they can have their own LTE network, the same technology that the carriers have been using for years, and that will evolve to 5G. Now, the interesting part about that aspect is, Nokia is known for our radio networks. We sell to all the big carriers. We're renowned for our radio and our core and our routers. But Nokia Enterprise also, developed through our R&D a solution, a Nokia Digital Automation Cloud, that took the carrier-grade solutions and software and capabilities and developed a solution that is more plug-and-play, that fits more of the enterprise requirements, which is they didn't want to become LTE experts. They wanted a technology, they wanted access to the LTE technology. Now they have the CBRS spectrum. And by the way, we have other spectrum we can offer them, such as band 53 from Globalstar and the multi-fire. But the point is now they have spectrum. Now they can access an LTE network, the same technology that's being used by the carriers, and they can do this now with a plug-and-play solution that makes it available for all enterprise.
So one of the more important critical points is basically when you are deploying a private LTE network, how much does it really cost? Everybody thinks that, carriers, AT&T, Verizon spend billions of dollars, not only in the spectrum, but deploying the network itself. This new concept that Nokia developed called Nokia Digital Automation Cloud, what we are doing is we are giving a very cheap, low-cost solution to the school districts, to the municipalities and other industries, and heavy lifting we are putting in a centralized cloud. So putting everything into the centralized clouds, non-essential part is shared. Basically the monitoring of the network, SIM provisioning and other things. They work as a tenants within the cloud itself. So that's how we are reducing the cost upfront for the end users and making it more robust for everyone to use at a very, very low cost, almost comparable to the Wi-Fi network. So having said that, if you look at the applications, what different applications are we using with the private LTE network? We have been working with different segments, like let's say in a school district, the typical example of the application is the pure data. Everybody wants to have a data connected to their phones, their laptops, dongles, you name it. But besides that, there are futuristic applications that we are deploying. For example, monitoring the campuses, security, surveillance. Also, for industries, everybody wants to use a push-to-talk. They want to have a walkie-talkie voice stuff application. Those different applications can be deployed using the private LTE network as well. Again, when we talk about the VoLTE, the service that you get from the AT&T Verizon, those applications also is available to you as well. You can have a roaming agreement with different operators. You can have an international roaming. You use the same device. You go out, have a data access outside your premises. Everything is permitted. It's the exact same carrier-grade network shrink down into a small version at a very low cost.
Yeah. Some of the differences when we get to know, we understand the difference between Wi-Fi and LTE and public and private. But I think for some of our customers, this is a new concept. So one of the aspects that an LTE network brings is security. The SIM encryption, we're used to SIMs in our phone, that provides a high accurate, a high dependable secure network. The other aspect of it is mobility. Wi-Fi going from one AP to another AP can have some glitches, it can delay, you don't have that with LTE. That's why the carriers deploy an LTE network, is because you can hand over, have full mobility. So when you're doing AR, VR in your facility, in your school, your factory, you can go from one AP to another AP, an LTE AP. So mobility is another aspect. The level of quality of throughput and latency. This is why verticals like the utilities and mining and manufacturing, they want their own LTE networks because they want that reliability of throughput and that reliability of latency. And then the aspect of, from a deployment standpoint, LTE one AP can propagate much larger. Usually it's 1 to 5, 1 to 7 LTE AP compared to 5 or 7 Wi-Fi APs. So when you're deploying in large facilities or trying to reach an outdoor campus, let's say, there's TCO, total cost of operation, because there's less APs required. And some of our customers, what they're looking at is not a wireless solution necessarily to replace a Wi-Fi or public LTE. It's to cut the cable. It's the Ethernet, the cost of running Ethernet. So now you can have cameras, IP cameras, that can go on a secure, reliable, high-speed, low-latency network.
Right. Okay, let's talk about the capacity. Everybody asks about what is the capacity that is needed, when you're deploying the private LTE in a school district or a campus area. So if you literally compare the Wi-Fi capacity, when you have a Wi-Fi access point, you can have up to 100, 150 users connected in the Wi-Fi environment. But this is not really a true capacity in the Wi-Fi environment, because as the number of users increases, your throughput, reliability, availability of the network reduces drastically. However, LTE sustain the network coverage capacity, because a small user, a small base station, we call a small cell in our LTE world, that can provide you up to 300, 400, or even 600 users, simultaneous connected users in the network. Now, from the throughput point of view, if you have a 20 megahertz channel, you can have 150 or maybe more than that megabits per second per user in the TDD mode. If you have carrier aggregation, you can go up to 1 gigabits per second type of throughput. Now, when you have throughput like this, huge throughput from one base station, you can have multiple base stations and you have a cluster of tens of gigabits per second kind of throughput. Now, another important thing about the private LTE is about your capacity, coverage, mobility and all that. So everybody asks, whether it's a small coverage area or a large coverage area. We did an experiment with one of the DoD customer. We put a small cell into a weather balloon and we got almost like a 60-mile coverage on the ground. So those are the capacity, in terms of coverage we're talking about. But when you have a lot of people in a small confined area, we shrink the coverage to a mile or maybe less than that, depending on what throughput you need. So it's comparable between how much throughput you need, let's say 75, 100 megabits per second, versus what coverage you need. So we can extend the range of the radios versus we can shrink the coverage in order to accommodate more number of users. Right?
Yeah, and then looking at a real-world example with K through 12, the school districts, we're asked, what's the kind of coverage and capacity I should expect? So, there is a limitation from a science standpoint. CBRS, the spectrum, the RF, CBRS is limited at a certain effective rated power. So we come up with a rule of thumb that usually within a mile and a half, or in an area about a 4.5 square mile per cell. So you can have multiple cells. And then in the cell itself, with LTE, you can have actually create sectors. So, for a cell that requires a high capacity area, you can have 6 sectors. So that would mean you have 6 different radios propagating. And then on top of that, Nokia has solutions where you have, 20 megahertz of channels, or you can aggregate as well and have 4 20 megahertz channels per sector. So then you're creating a significant amount of capacity. You also have 80 megahertz of bandwidth per sector, per cell. So these are the kind of solutions Nokia is offering to the K through 12 and higher ed and other verticals that are looking for a high capacity solution within a confined area, and they create that LTE bubble within that confined area.
So what is CBRS actually? So CBRS is our citizen broadband radio solution that has been provided by the FCC. It's a 3.5 gigahertz spectrum where you have 150 megahertz available for public use. There are 3 tiers in this spectrum. First one is called incumbent, where Navy radars and others, government officials, they can utilize this spectrum, but they're not using the entire 150 megahertz. They're using a small bit of it actually. Then second part is a priority access license, where you can have a auction. You can go to the auction and get the license from the government, from the FCC. Then large portion, which is 80 megahertz, is generally available for public. Just like Wi-Fi, you have an access point, you go to the SAS vendor, connect your access point to them, and you are allowed to transmit these bands. So you have all these, and in fact, the priority access, if you are transmitting into the GAA and nobody is having the priority access license in your area, you have access to that spectrum as well. So point is, you have abundant spectrum available, from different vendors. Sometimes, people have already got some access from the from FCC on the priority access, and if they are not utilizing the spectrum, you can have that access as well.
And I think pointing out, this creation of the SAS is, I think, kind of brilliant from the FCC standpoint. What they defined it is, yes, there are, licenses where you have priority and you have access to these licenses. But if in your specific, let's say, school district, even if they have the license but they're not using it, it's a use it or share it model. So you have access to that GAA, and then on top of that, you have access to potentially another 70 megahertz of spectrum that may be licensed out to somebody else, but they may not use it in your area or aren't effectively using it. So it's a use it or share it spectrum.
Okay, let's move on to the next one. So this is also illustration of the GAA, you know, how the spectrum being monetized. General authority access is the one which is, you know, available to everyone. You know, just go there and use 20, 40, 60 megahertz, whatever the spectrum is available. Like Ray said, we have to connect to the SAS vendor where your spectrum utilization is being monitored. Then priority access is mainly for the utility and, you know, oil and gas and other industries where they have, you know, mission critical application deployed onto those spectrum. And then obviously the incumbent that we talked about.
Yeah, and one other point too, please realize though CBRS has been the catalyst for private wireless, Nokia also has access to other spectrums such as band 53. We partner with Globalstar. There's other ones like the multi-fire. So though CBRS is probably going to become the main spectrum that private wireless will be deployed on, there are other options.
Yeah, in terms of the spectrum, you know, we're not really limited to the CBRS. CBRS is easily available. That's why we always talk about it. But there are certain applications, let's say mission critical application or business critical application, where you cannot see any kind of degradation in the service, or you want to have more bandwidth. Let's say you have a, you know, 80 megahertz from CBRS, you can go up to 600, 700 megabits per second, but your requirement is more than a gigabits per second for one user. In those situations, we do the carrier aggregation or deploy the 5G network with other, you know, licensed spectrum as well in the millimeter and centimeter wavelengths. So it's not really limited to the CBRS. CBRS is easily available, you know, cheap, almost like no cost, and that's the reason why we always talk about the CBRS in United States. Let's talk about, you know, what exactly the constitution between Wi-Fi and your traditional Ethernet or fiber network. So when you talk about the private LTE network, it brings the security, you know, reliability, you know, high capacity from the Ethernet side of the world, and then you put, you know, mobility part from the Wi-Fi side. You can move around, you can go up to 350 kilometers per hour speed, and you have seamless connectivity from your device. In comparison to Wi-Fi, when you can have a mobility at a very limited, you know, span, you can only walk around or you can go around, and then you have to make a handover. Every time you make a handover, you have to drop the session and so on and so forth.
And I think one aspect of it is there's the differences between LTE and Wi-Fi, but then from looking at it from the commercial public LTE and a private LTE, the reason certain verticals and enterprise and school districts are looking at implementing that LTE technology, not from the carriers, but owning it themselves and having that private is, A, yes, of course, they get the advantages of LTE, the security, the bandwidth, the mobility, but then they're able to control that network at that point, and control from a standpoint of securing that data, putting the data on the edge, on an edge server, and stays within their IP network. So everything they've implemented within their IP network is now really an extension with the wireless aspect of it. So that plays a large part. And then prioritization, you know, we talk about data plans that are unlimited, but then end up not really unlimited because there's data throughput. You know, they reduce the availability. Now with a private LTE network, there is no, you know, turning down the amount of throughput that's available to you, or the amount of subscribers you can have on that network. And also then you can even prioritize who gets the you know, either compute power from the edge standpoint or that spectrum or that available capacity. Enterprise are now able to control their network. That's a big difference between the two.
Absolutely. All right, and that's all from us. Thank you very much for having us here.
Guys, thanks very much. Appreciate it. Ray, Dharmesh, really appreciate it. Guys, just so you can see, this just shows you there's another area that Netsync's trying to bring to you guys. We want to make sure that we include our expert partners. As you can tell, we've got a lot of expertise, and more than happy to have follow-up questions. If you guys do have questions, please reach out to your local Netsync rep, and they can get us get in touch with our team, and we can leverage the relationship with Nokia and bring the experts in to help you with solving your problems. Thanks again. Thanks for joining us.